Thank you very much. First of all, I would like to thank the organizers for providing such a platform and for exchange and for inviting me to this meeting, although I come from a bit of a different research area. I'm very excited to be here and to share my ideas on research that is of a bit different point of view. So we humans, we have a natural ability to navigate and to learn during navigation. So to make it easier for us, developments in digital technology provide us assistance for these tasks. Now, what most of you might understand as a navigation system is this one here. So it is a digital map that allows us to have spatial data, and it allows us to zoom in or to zoom out again, and even to rotate and change certain layers. But also this here needs a navigation system where the user can zoom in into more detailed information on a specific topic, but also can zoom out again. And sorry about that. You can zoom out again or go deeper into this topic that you're interested in. So we use both of these navigation systems for specific tasks. And we would like to reach a specific goal or also a destination, and of why we want to use it in the first place. So for both of them, first of all, information is organized in a specific way. On one hand side, it's very spatial. On the other, it's in a different form with a different navigation system. But we also have interactions that allow us to navigate and to keep the orientation within the area that we're looking for information. Then the third point is that the usability of both of these navigation systems should be very easy. It should be fast and also fun to use, and that it allows the user to find very quickly what they are looking for. And fourth, the design, it also affects the mental representation of that information. So decisions on what we display on the navigation system, how it is displayed, how detailed the information is on what layer and for what task we use it for, are very crucial design decisions for both of those navigation systems. So there are more similarities, and not only content-wise, but also how a user navigates than you might have thought in the first place. But what's the problem? Well, in various everyday situations, the devices are the focus of attention, and the reputation of navigation systems is very bad and as it has negative effects, such as degradation of navigation skills, the environmental awareness decreases, it divides our attention between the environment and the device itself, and it also affects learning and memory ability. So there are a lot of research at the moment out there that state these negative effects. And that's because most of those navigation systems, they are designed to perform tasks that used to be done by humans naturally, but in a way more efficient and effective way. That they allow for high usability. So as I mentioned, that it's easy, very simple, and also fun to use. And it's mostly designed, the traditional navigation system are designed for car navigation. So the data relies on car navigation. So one of the most crucial findings is that these navigation systems, they do not allow us to build up a mental representation of the traversed space and the information space that we navigate, whether it's digitally or also physically. And the result of that is that most of the people, they even feel lost or disconnected when not having their device with them. And because these findings lead to a very bad reputation of navigation systems, and I'm a big fan of maps and map navigation, lead me to my PhD research. And to bit understand also for the audience that mostly come from a neuroscience field of study, to understand my point of view is that I'm coming from the geography department, and my research goal in my PhD was whether it is not possible to design navigation systems that on one hand side ensure efficient navigation and effective navigation so that we actually reach the destination, but at the same time allow us to learn the environment and to build up a mental representation of the space. So specifically, I studied the effects of human-centered navigation systems on pedestrian navigation behavior. So I conducted empirical user studies in an outdoor urban environment with pedestrians. And the results showed that it is possible to have the navigation system designed that it allows for efficient and effective navigation, and at the same time that the users can build up a mental representation to walk that route again. So one of these facts, efficient navigation does not exclude learning, just the navigation system design has to be designed respectively. Today in my talk, I'm not going to detail on the study results and how exactly the experiment was built up. You can find more on that on an open access journal called How Does Navigation System Behavior Influence Human Behavior? It's the first study that showed that it actually is possible and that those two factors do not exclude one another. But with knowing now, after my PhD, that efficiency does not exclude necessarily learning, I started last year my job as a user experience architect, and I'm dealing with a lot of products and with user-centered design. So the goal of my work is to make digital products user-friendly and structure the product in a way that it allows a user to more easily find what they're looking for and to optimize the process of actually reaching the destination, which is why they use the software or the digital product in the first place. But also here, I realized that most of those products are designed for efficiency reason and do not take the mental model, the existing mental model of the user, and also how the information adds then to that mental model of the user. It doesn't take it into account. So as you see, I can already, maybe from what I've said before, but I identified similarities of navigation systems between my research background of geography and my current work as a UX designer. So I would like to very briefly introduce you 5 key principles of the cartographic navigation theory that influence behavior and learning, but also not only navigation system, but how they relate to digital products as well. So the first of those principles are landmarks. And during navigation, we naturally collect landmarks. And landmarks are objects that structure human mental representation of space. So they're kind of a snapshot that shape human memory and that grab our attention as it stands out from the rest of the information provided. So with the interactive map that we have now, it's not a paper map, but it's interactive, and it allows the user to be able to constantly change the information. So for example, we see here a landmark of a museum in Zurich, so the Schweizerische Nationalmuseum. And then we can zoom in. So the map changes. There are different points of interest. We can zoom out again. We have a different view. We can again zoom in. We can even rotate the map. We zoom in there. We rotate it again. So the content changes constantly. So for the user who has now unlimited access of these points of interest, and to choose a landmark from that is quite difficult. And so it's no surprise that it's hard to build a mental model from that area. And the same goes with the behavior of the user of a website. So if the user can constantly or shows a behavior and constantly interacts, like looking for the neuroscience information, then goes back again, scrolls down, goes into the doctoral degree information, go back again. So if the behavior of a user is like constantly changing and has no real route and no clear flow, it's hard to orient. It's a sign that the user has difficulties to orient and to also build a mental model of that information space here. So what we can say is that a good navigation system helps the user to navigate at a certain level and then allows the user to look for the information at that level and have it. And if going back and forth, it confuses and it is difficult to have then a sense of orientation within that space. So we should ask ourselves after using one of those navigation systems, what did the users learn from it and what was it what they were looking for in the first place? A second principle is that a navigator is always embedded in a specific environment. So where is the navigator while using the navigation system, and how does this environment influence the navigator itself? So we are always in an environment, and that environment can be very old, very unstructured. It can be very modern, very structured, also very boring. It can be very full of dynamic, different people. So whenever there is a structure around the user, it can distract, support, but also hinder to keep oriented. And also that affects human behavior. So if an environment gets busier and constantly changing, it also changes behavior with the navigation system. And so the navigation system should also take that into account. So independently of the navigation system, the question asked here is, where is the system being used? Is it in a very quiet office, or is there a lot of people around that constantly talk on the phone? Is it used in a more open space and people can just pass by whenever they are interested in looking at your screen? Is it used while driving? So is even the user moving with the navigation system, for example, here? Or is it even outdoors? How is the lighting condition? How does that affect design and the behavior with the navigation system? And even, is it loud? So there are different levels that can influence how the behavior with the navigation system can be changed and how it influences the behavior and learning with it. So we can say that a navigation system should be adapted to and consider the environment as it affects behavior and also learning. And when the environment, what we've seen now, that the environment influences the user, it also uses where influences where the user allocates his or her attention, whether it is relevant information or not. So there are structures that can interrupt the flow of allocating attention and lead to dividing attention effects. And therefore, in collecting information, to build a mental representation might get more difficult. So in my PhD, I also analyzed eye tracking data from pedestrians. And the distraction from the environment does not simply come from the navigation system itself, as some of the studies suggest, but also from other pedestrians coming your way, which, for example, shouldn't happen while you drive a car, from watching your steps while crossing a street, and also from linear features that restrict your field of view, usually to one side quite heavily. So a pedestrian environment is quite different to that of other road users and features different challenges, and also with that influences how a user can allocate attention. So urban planning and design here, for example, in that example you see for pedestrian, it has an influence on allocating attention during navigation tasks and should be therefore part of studying navigation systems, as it's just very different and features different problems. So the distraction definitely works against cognitive offloading, and it can not only come from the environment, but also from an interface and from displayed information. So here is an example of a form filling process. Here, the user doesn't have a clear flow. The user does not know where to allocate attention first, and then maybe the first one is easy, the first name, but afterwards it gets more difficult. So where should I go next? And what happens if I just type enter? Where does it go next? So the attention is quite difficult to allocate. So also design here matters, and it can be made easier or more difficult for the user. So we can say allocating attention, it happens to the environment, but also within the system itself. And it can be built easier or more difficult for the user to deal with, and should therefore be taken into account, as it impacts not only behavior, but also learning from it. Then the fourth principle is the representation. So maps often use symbols to represent features from the real world. And that is an important fact, aligning representation to the real world. It is important because it facilitates efficiency and efficient navigation to keep oriented, and it often relies also on existing knowledge of the human user. So for example, signs, such as here the underground sign, we learned it very early on that it looks like this. It's very easy to find, and the map should match the symbol then from the real world to allow efficient navigation and to align the representation to the real world. A similar example is in other digital products, for example, for Google Slides that is used for presentations, for example, like this one. So the first time I used this symbol here, so if I don't want to show one of the slides, I learned that this symbol is an eye that is crossed. So for me, my mental model tells me that is hide this slide. However, now every time I use that software, I get this as an option. And I'm looking for hide slide because for me, the sign of a crossed eye means hide slide, but the option is only skip slide. And so for me, this is more effortful, and my mental model does not match what I get as an option. It's a time-consuming process to look for it because I can't update it. I can't change what I'm looking for. So the navigation system should match representations not only to the real world, but also to existing and gain knowledge from the user itself. And then the fifth principle, and that is a highly discussed principle in the field of navigation, are nodes. So nodes are intersections and points of decision making. So at nodes, errors are possible, navigation errors are possible. And therefore, it is important to provide clear choice options and clear instructions of where to go next. So at a complex intersection, like this one here, for example, in Paris, the instruction of when you think of coming from the blue line to, if the instruction is just to go left, it wouldn't be a very useful instruction for the user here. So the user does not want to explore all the options first, which could be left to find the destination. It would not be efficient, and from a motivational point of view, that doesn't make sense to choose all the options. So the instruction should be very clear. The same goes for an application from Zurich Transport. This is an app to buy a ticket. So if my use case is to buy a ticket, this interface here, which I'm going to enlarge a bit, that you can read it, it's not very clear. So a shop, maybe I get there as well a ticket. There are check-in tickets, then an abonnement, this is a specific type of ticket. Then there are tickets, and a multi-ticket is a thing here in Zurich where you have several tickets on one ticket. So this node is difficult for me as a user, as all options could leading me to the destination of getting a ticket for public transport. So the user here has only the option to try out all the options that I get. That is not efficient, it's not fun. And next time I'm using this app, I still have probably the same choices. And unless I checked all the options, or unless I took the first choice that was the right one, I can't remember it next time. So the navigation system, whether on spatial data or not, should provide clear instructions of where to go next. If the next step is clearly distinguishable from the other option, it is also easier to navigate there again next time. So I introduced to you now these 5 principles that are important in cartographic navigation theory and that are relevant for the analysis of human navigation behavior in the wild and are shown to matter for behavior analysis and for learning processes. So if we apply and consider these principles into navigation system design, we can also ensure that users learn. And if the system supports learning and adding to a mental representation of the information that's provided, we can also ensure that the user does not only have a user-centered system, but also allow to design more human-centered navigation systems. So as a take-home message, I think it's important to understand the parallels of behavior and learning from different navigation systems, whether it's with spatial data or different data as a map, an application, a software. Digital devices need navigation systems. So a second important take-home message, which I think is very crucial here, is to include the real world when studying human behavior and learning processes as well, as it shows there are different influencing factors that should not be neglected in designing future navigation systems. And the last and one of the most important parts is that we should design navigation systems to complement humans and not only to compete with them. So if they allow us to be efficient, maybe they can also allow us to learn from them. So I hope that you got some insights into more human and user-centered navigation system, and thank you all for listening.